Right, in this video, we're going to be talking about suggested homework problems from 3.5. It's going to be very important in this section to follow the techniques that are presented in the notes and in the textbook, and not to go outside the notes in the textbook and use means that were not discussed there. There are other techniques um, that you may learn in other calculus courses later, or that you may have learned in another calculus course previous to this. Don't use them if they haven't been presented yet in this course. That's just a word of warning to you that this section is to teach you very specific techniques, and you'll be tested on your ability to apply those techniques and not other techniques that show up later in calculus. All right, so let's look at number 5 first. And this is matching, so I'm actually going to go down to the I'll have to draw a sketch and then match it for you. So f of x is equal to 2x squared over x squared plus 2. So as we analyze this graph, there's not going to be any vertical asymptotes in this function or in any of the other functions, because x squared plus 2 is never equal to 0. Doesn't matter if we take the square root of it or anything like that. It's always a positive number, so there's no issues with it. And any of the denominators that we have here, that's why it was chosen. So let's focus on the fact that there's an x-intercept here at 0, 0, which means there's also a y-intercept at 0, 0. Now let's look at those asymptotes, and let's prove them with calculus. Let's not just use our pre-calculus techniques, because we're in calculus now. So limit as x approaches negative infinity of 2x squared over x squared plus 2. And I want to divide everything by the highest degree that I see in the bottom. So I'm going to multiply by 1 over x squared over 1 over x squared. This gives me a limit as x goes to negative infinity, 2 over 1 plus 2 over x squared. And so this is going to be 2 over 1 plus, and then 2 over negative infinity squared. So that's 2 over a really big number. So, but it's positive. So this is going to be getting close to 0, but it's a little bit positive. And so that gives me that this is approaching 2 over 1 from the right. So I'm dividing 2 by a number a little bit bigger than 1. So this is approaching 2 from the left. Or I'm sorry, not from the left, from the, this is from the top. This is from the right. This is from the bottom, because I'm talking about the y value now. Okay, so so a number a little bit bigger than 1 dividing into 2 is going to be a number a little bit smaller than 2. That's really what I'm saying there. So kind of the idea of which side is it coming from. So we're approaching y equals 2, but from underneath. Limit as x approaches positive infinity of this function right here is going to give me the same thing. So in both cases, we want to approach 2 from the bottom. Let's see which one does that. So approaching 2 from the bottom in both the left and the right with an x-intercept at 0, 0 is f. There we go. Let's look now at number 6. Six says f of x is equal to 2x over root x squared plus 2. Again, domain is all real numbers. We again have an x-intercept at 0, 0, which is also our y-intercept at 0, 0. Let's take our limit now. After we rewrite this function as such, 2x over absolute value of x square root 1 plus 2 over x squared. So this is going to break apart into two pieces here, where this is 2x over negative x root 1 plus 2 over x squared when x is less than 0, and 2x over x root 1 plus 2 over x squared when x is greater than 0. When x equals 0, I'm not really interested in that with my limits, but when x equals 0, I already know that it's 0. So limit as x goes to negative infinity, we're going to use this piece when x is less than 0, negative x root 1 plus 2 over x squared. So the x's will cancel, leaving me with limit as x goes to negative infinity of a negative 2 over root 1 plus 2 over x squared. This is getting close to 0 from, but a little bit bigger. So this is getting close to 1, but a little bit bigger. And the square root of a number that's a little bit bigger than 1 is also going to be a little bit bigger than 1. So this is going to be negative 2, but a number that is a little bit bigger than that, because the absolute value would be a little bit smaller than 2, but it's in the negative direction. We're a little bit closer to 0, so that's above negative 2 or to the right of negative 2, however you're looking at that limit. As x goes to positive infinity, this is 2x over x root 1 plus 2 over x squared, and the x's will cancel. Limit x goes to infinity of 2 over root 1 plus 2 over x squared is 2 over, and then again, this is going to be a number a little bit bigger than 1. So this is going to be a number a little bit smaller than 2. So on the left-hand side, we approach negative 2 from above, and from the right-hand side, we approach 2 from below. So let's see if we approach negative 2 from above. Right here, and positive 2 from below. That looks like C. We have an x-intercept of 0, 0. That certainly looks like C to me. Negative 2 from above, positive 2 from below, intercept at 0, 0. All right, let's look at number 7 now. F of x is equal to x over x squared plus 2. So again, I'm going to multiply by 1 over x squared, 1 over x squared. F of x is 1 over x over 1 plus 2 over x squared. Limit of f of x as x approaches negative infinity. That's going to be a number a little bit less than 0 because it's going to be a negative number. And then 1 plus a number a little bit bigger than 0. So this is number a little bit less than 0 over a number a little bit bigger than 1. So this is still a negative divided by a positive. But it's really close to 0. This is getting close to 0. And it's slightly negative here because this is a negative and this is a positive. So limit of f of x as x approaches positive infinity is going to be 0 from above, 1 plus, and then this is also 0 from above. So this is positive divided by positive is going towards 0 from above. And so we have a x-intercept at 0, 0. Let's see if this matches up with anything. Getting close to 0 from below, 0 from above, 0, 0. So B is a candidate. 0 from below, 0 from above, D is a candidate. And then let's see. So B is actually crossing the x-axis multiple times. We'll see that later. But there's actually 3 x-intercepts shown there. We only have 1 x-intercept at 0, 0, so it's not B, it's D. So this is D. We also could figure out some other information, such as that the y value of x being equal to 1 is 1 over 3 is a third, and we could look for 1/3, that it's the y value is going to be less than 1 here, so it's 1/3, as opposed to B has 1, and then it looks like almost 2. It's something bigger than 1, so that would also be an identifying factor for us there, that what are some other function values and which one maps to the correct values. All right, that was number 7. Let's look at number 8. Number 8 says that f of x is equal to 2 plus x squared over x to the 4th plus 1. So I again am going to multiply by 1 over x squared over 1 over x squared just to this part that has the x's. I'll leave the part that's the constant 2 alone. So f of x is equal to 2 plus 1 over x squared plus 1 over x squared. Limit of f of x as x goes to a negative infinity is going to be equal to 2 plus 1 over, and then this is going to be positive infinity in the bottom here. So this is a positive divided by a positive. This is 2 plus coming at 0 from a little bit bigger. So this is going to be a number a little bit bigger than 2. Limit of f of x as x approaches positive infinity is 2 plus, and again, this is going to be positive infinity. So same thing, that I'm coming from a number a little bit bigger than 0 gives me a number a little bit bigger than 2. So approaching from just above 2 both times. Let's see if there's any other options. It looks like the only option there is A. So that's A. I don't really need to go into anything else. There were not going to be any x-intercepts here, because when I let x be equal to 0, well, for my y-intercept, when x is 0, then we have 2 plus 0 is 2. So there's my y-intercept. If I try and set everything equal to 0, this x squared over x to the 4th plus 1 is a positive over a positive, and it can't ever be equal to -2. So there are no x-intercepts there. Let's continue with number 9. Number 9 says f of x is equal to 4 sine x over x squared plus 1. A little bit more complicated, more than a little bit more complicated. But think about the repeating pattern of sine to get our zeros of the numerator. So 4 sine x equals 0, sine x is equal to 0. X is going to be 0, negative pi, positive pi, positive 2 pi, negative 2 pi, so on this way, and so on this way. So that should already tell you which one it is. I already talked about this, that this is 3.14 that crosses here, roughly where pi is, negative 3.14 roughly where negative pi is. That we can just kind of eyeball that and say that's pretty close to positive pi, that's negative pi. And this is going to keep going. If we wanted to prove with limits that this was approaching 0 from above and 0 from below, limit of f of x as x approaches negative infinity is going to be, we're going to have to say that this is going to stay between -1 and 1 for sine. So we have -4 over x squared plus 1 is 4 sine x over x squared plus 1. Limit x goes to negative infinity of +4 over x squared plus 1. And that both of these sides go to 0. So this limit has to stay between. And has to go towards 0. I don't really know from, because this crosses and comes back and crosses and comes back, I can't really tell you where it's above and where it's below, but I can tell you that it's getting closer and closer to 0. On the left-hand side, it's likewise going to do the same thing on the right-hand side, that if I write this as -4 over x squared plus 1, limit x goes to positive infinity, 4 sine x over x squared plus 1, limit x goes to positive infinity, 4 over x squared plus 1, it will likewise stay between 0 and 0 and go to 0. So we have all the evidence we need that that's B. Let's wrap up this little part of matching here with number 10. F of x is equal to 2x squared minus 3x plus 5 over x squared plus 1. So again, multiply by 1 over x squared, top and bottom. So f of x is equal to 2 minus 3 over x plus 5 over x squared over 1 plus 1 over x squared. Limit of f of x as x goes to negative infinity will be 2. And then a negative divided by a negative is a positive. And then this is positive here. And then this is a positive here. So I get a number a little bit bigger than 2 over a number a little bit bigger than 1. And I'm going to say that this positive divided by this positive is approaching a positive 2. And let's see that this is from the left-hand side. This is from above. And then limit of f of x as x approaches positive infinity, that this is 2. It's a number a little bit less than 0 plus a little bit bigger than 0 over 1 plus a number a little bit bigger than 0. And so this is going to be, don't worry about this above and below. This is basically 0 and 0 here. And 10. This is going to be E. So this is also going to be approaching 2. This is from above, this is from below. And so we get E right here. We're on the left-hand side, we're approaching from above. From the right-hand side, we're approaching from below. All right, enough of that. Let's move on to our next problem, which is number 13. Make sure I don't miss anything here. Okay, number 13. I think a little easier than the graphing. Same procedure as I did. I'm going to use negative exponents instead of writing fractions now. I think that you get an idea what I'm talking about, and that it's going to be easy for me to say that anything where I end up with a negative exponent is going to go to 0. This is going to 0 plus 0 over 1 minus 0. It's going to 0 over 1, which is 0. That's for part A. For part B, we have limit as x goes to infinity, x squared plus 2 over x squared minus 1, multiplied by x to the negative second over x to the negative second. Limit as x goes to infinity of 1 plus 2x to the negative second over 1 minus x to the negative second is 1 plus 0 over 1 minus 0 is 1 over 1 is 1. And then for part C, limit as x goes to infinity of x squared plus 2 over x minus 1, and going to multiply it by x to the negative first over x to the negative first will be limit as x goes to infinity of x plus 2x to the negative first over 1 minus x to the negative first. So that's going to be approaching infinity plus 0 over 1 minus 0. This is all conceptual here. Don't actually write that is going to infinity. But you're thinking about this. So you're going to say that your answer is infinity and that the limit does not exist because it increases with that bound. Okay. Let's move now to our next problem, is number 17. Limit as x goes to infinity of 4 plus 3 over x will be 4 plus 0 is 4. 21, limit x goes to negative infinity. 4x squared plus 5 over x squared plus 3 is limit as x goes to negative infinity of 4 plus 5x to the negative second over 1 plus 3x to the negative second is 4 plus 0 over 1 plus 0. 4 over 1 is 4. Let's continue now with number 25. Number 25 says limit as x goes to a negative infinity of x over root x squared minus 1. There's a couple of different ways to think about doing this. I like to use the fact that the absolute value of x is equal to the square root of x squared. And to see that limit as x goes to negative infinity of, and that this is the square root of x squared times the square root of 1 minus x to the negative second, that I can multiply inside the square root there, and x to the negative first, and I can get the same thing, that 2 minus 1 is an exponent of 1, and 2 plus 0 is 2. So this is x. And then when I'm on the left-hand side, this absolute value here is a negative x. So that this is x when x is greater than 0, and negative x when x is less than 0. So limit x goes to a negative infinity. I'm on the left-hand side here is x over negative x root 1 minus x to the negative first is a limit as x goes to negative infinity of negative 1 over root 1 minus x to the negative first, negative 1 over root 1 minus 0, which is really 1 plus 0 because it's minus a negative number, is negative 1 over root 1 is negative 1 over 1 is negative 1. That was number 25. So let's look now at number 33. This one I'm going to have to use the squeeze theorem. So 33 says limit as x goes to infinity, 1 over 2x plus sine x. 1 over 2x plus sine x is going to stay between 1 over 2x plus 1 and 1 over 2x minus 1. So smaller denominator, bigger function value. Bigger denominator, smaller function value. So when I take the limit of everything here, because the denominators are going to positive infinity, 1 over infinity is going towards 0. This limit as x goes to infinity of 1 over 2x plus sine x has to stay between this lower limit of 0 and this upper limit of 0. So this limit as we go to infinity, 1 over 2 x plus sine x has to go towards 0. Let's see now. Number 53 is next. All right, so this is just a conceptual question. Explain the difference between a limit at infinity and infinite limits. So a limit at infinity is what we were just talking about, where x approaches positive or negative infinity. typically talks about a horizontal asymptote, though it could talk about just any old end behavior of the graph, that it approaches a slant asymptote, or that it goes to infinity or negative infinity, but limits at infinity describe the end behavior, the right and left end behavior. It's at infinity, describe the end behavior. Yeah. Of the graph. So limit as x goes to negative infinity of f of x is equal to your left end behavior, and limit as x goes to positive infinity of f of x on the right is your right-hand side end behavior. Infinite limits, on the other hand, are a way to describe limits that do not exist because they increase or decrease with that bound. So you saw me say that earlier about one of the problems, that the limit does not exist because it increases with that bound, or the limit did not exist because it decreases with that bound. So now that we understand that, with horizontal asymptotes, can the graph of a function cross the horizontal asymptote? Absolutely, yes, it can. We already saw that happen. Yes, so just go back and look at, which problem was it that we already did that did that? The graph for part E of the matching, right? That it crosses through that horizontal asymptote at y equals 2 and then comes back from below. So same thing with B, that it crosses through the horizontal asymptote several times, but it just approaches. So C graphs B and D, no, B and E from the matching problems that we did first. Okay, so we have two examples there of that occurring. So of course it can happen. So let's look at number 56. I believe this will wrap things up for this video. Yes. So the graph shows the temperature, capital T, in degrees Fahrenheit of molten glass, lowercase t seconds after it is removed from the kiln. So as the limit as x approaches 0 from the right, to get close to the starting point right here, what does that limit represent? That would be the temperature of the kiln. And limit of capital T as t approaches 0 from the right is equal to 1700 degrees F. Part B, what is the limit as t approaches infinity of capital T represent? It's going to equal 72 degrees F, and this represents room temperature. Okay, so that's it for this video. We'll come back next time and we will talk about section 3.6. See you for the next video.